Hello. First, some reminders of things we did before. The key ideas or concepts in the field are data, which is the raw bits and bytes produced by instruments or gathered from the web or email and social media sites. There's information, which is the cleaned up data, but without any deep processing applied to it. And then we have something which is called knowledge, wisdom, and decisions, which come from analyzing the information. There are gray barriers between data or even raw data, information, knowledge, wisdom, and decisions. But the general idea that we go from um, the raw bits and bytes through a variety of filters, each time adding value and usually reducing size, but not always, is important in all areas. We have the field of data analytics, which is the process of converting data to information or information to knowledge. Namely, it's the field that studies the transformations or filters that convert the forms of data into a higher value form. Finally, we have data science, which describes the whole process. And we have X Informatics, which is the actual application area for which we're doing this. And of course, X refers to the different fields. As we said last time, the course in one sentence is studying clouds, running data analytics programs, processing big data to solve issues or problems in the field of X informatics. And as discussed, we will have the following structure of the course, um, which will be this initial survey, followed by use cases which study um, big data in various application areas. And we will possibly use Python in some of the applications, not all of them. But the language used, the course will be, whenever it is used, will be Python. And sometimes we will also use online resources to explore different areas. Um, and we will actually survey some use cases as a sort of project in research in that area. The last slide from the previous lecture is given here just to bring us back to square one. That is the slide that where we pointed out that an interesting area of big data is which comes from the Internet of Things broad area, which is the monitors on engines. And this came from a presentation from General Electric, and where it points out that the amount of data in this area is very large, and then that they I know it's on what they do or they could do, but they monitor in real time their entire set of 25,000 engines, um, gathering that data, looking for anomalies, and taking preventive action um, when the planes land. So now we continue big data in business. Um, and the first slide, I mean, these are a set of slides I gathered from the web just to summarize that area. The first slide is one from a speaker in SAS, which points out that the issue for statisticians, which is um, which have opportunities, which are building these integrated software solutions for business problems, or at least applying the statistics part of that. And they identify various applications, fraud detection, credit risk, credit scoring, analysis of warranty data, customer retention, that's analyzing what causes people to leave or not leave their phone subscription, and then the important area of optimizing pricing in the retail business. Now we come to a set of slides coming from a talk from Williams from eBay. And the first slide is a statement as to what eBay does. Namely, it sells Mustangs every 49 minutes, cell phones every 5 seconds, and shoes every 6 seconds. Pretty fancy shoes. Here are some statistics on the actual volumes of activity at eBay. They have 108 million or more than that of active buyers and sellers worldwide, 250 million queries to their search engine, 350 million live global listings. They have 20 petabytes of data, and they use a mix of Hadoop, which is MapReduce, and more traditional database using Teradata solutions. And they have 2 billion page views every day and 75 billion database calls every day. So here's eBay's view as to why big data is transformational. In this regard, I was at a meeting at NIST January 15, and at that meeting, it was stated that big data is the killer application for clouds, which is consistent with this view. The big data analyzed, of course, on clouds is a transformational or disruptive technology which is changing many fields. And here, eBay points out that big data tells you about patterns, which we'll give an example of, anomalies and outliers. It generalizes micro transactions to broad principles. It gives you predictions and a holistic customer picture. And it has, as they said, many applications at eBay, from system performance, fraud detection, predicting purchases, customer support, product development, and so on.